बन्नी पाड़ी मैडम आप ओडिशा रू की
एक
ఇందాకే వాయిస్ వచ్చింది మా
ఏంటి గోటి
Good afternoon all. Am I audible? Yes, am I audible?
yes sir
Right. Let's start the class. Is there any waiting for any other person? Only 22 attendance for about 420 strength. Only the 22 people are interested to listen the classes. Remaining part 400. What's happening to for remaining 400? They're very much busy. Yeah. Okay. Whatever it may be. Can I off the my video? If you have any doubts, you can ask me. Or if you want to you need to talk to me, you can ask me to on the video. I can on that. Okay. If someone is sent the message, okay. Because it will be it is disturbing to write whenever I am writing on the pad. Okay. That is the reason I am closing my video. If required, you can ask me. I cannot. Don't worry. Okay. Yeah. Okay. Now, in continuation to the next class, the previous class, we are discussed about the nomenclature of previous class. The continuation to the previous class, today the nomenclature for fused ring systems. Yeah, my cursor is movement of cursor is showing you. Is it visible to you?
Yes, sir. It is visible.
Yeah, right. Nomenclature for fused ring systems. Suppose any compound, it is only ring system. It is known as monocyclic system. Monocyclic system, right? Suppose this monocyclic system is like benzene. Now it results not in bicyclic system. It's a fused cyclic. Or you can also simply call it bicyclic. Two rings are there, then simply call it as bicyclic system. And it is a fused ring system, right? That means any compound existing with two or more than two are known as fused rings. Fused ring compound. Generally, suppose when the compound is constructed with the, suppose you take the naphthalene, then it is a carbocyclic. Suppose if any carbon is replaced with like nitrogen, like hydrogen, this is called heterocyclic. Heterocyclic, right? Now, when you're coming to this is called as naphthalene. Naphthalene. Now its name is quinoline. Quinoline. Or we can also name it as, this is the benzene, this is the pyridine, this is the benzene. Now here the priority is we are going to give the nomenclature for the heterocyclic ring. Now the compound base name will be the pyridine. and the prefix should be this carbon. That is otherwise it is having a common name, a trivial name that is known as quinoline. Whenever the trivial name is available, no need to use this kind of nomenclature. This is wrong, right? This compound is having trivial name. Then when the trivial name is available, no need to go for the IUPAC name. That is a more preferable one. IUPAC is already accepted. IUPAC is also always directing to use the trivial name in the case of heterocyclic compound. Suppose if you want to give IUPAC name as per the IUPAC rules, that is also acceptable. That is also acceptable. But most commonly, we need to give the compound name based on the trivial name. Okay, because the trivial names are highly popular and easily identifiable. Due to that reason, whenever you are going to give the name for the heterocyclic compound, first you need to give the priority to give the name by using the trivial words, trivial name words. Okay, that is the reason we can call it as benzopyrrole, sorry, quinoline. Or if you are unable to remember this, you can also use the benzopyridine, or also a pure IUPAC name azanaphthalene. Can also use the name azanaphthalene. Right? If these three names are acceptable and every case we can use it. Okay, these are known as fused ring system. Fused ring system. Now with this name, whenever we are going to give the azanaphthalene, this name is called replacement nomenclature. Replacement nomenclature. Replacement nomenclature. Okay. Replacement nomenclature. Now, what are the rules you need to follow? Suppose in most of the cases, whenever you are considering the fused ring systems, more than one heteroatoms are generally appear. If only one or single heteroatom are there, suppose single heteroatom is present, name is given as follows. For example, you take nitrogen, single oxygen containing heterocycle. That is called this ring known as benzo. This is called as prefix, and this is the master one or base system, furan. Now, always single heteroatom is there. Then the numbering starts with 1, 2, 3, right? 4, 5, right? Whenever we are assigning the complete name, we can also use 4A and then the number A. Do the labeling for these bonds A and B. Now the name is the number is 4, 5. That means whenever you are considering this separate ring, this is a separate ring. When the separate ring is taken, how you need to give the label? 1, 2, 3, 4, 5. This bond is the fused one. This is the common bond between the two ring system. Right. Now, for indicating the fused bond, this is the CO bond is the A and it is labeled with B. Now the fused bond is B. Now 4, 5 B. The heterocyclism is furan. Benzo B furan. That is the name of the compound. Similarly, you can take other heterocyclic compound. Simple pyridine. Quinone is there. The numbering starts with 1, 2, 3, 4, 5, 6, 7, and 8. Right. But whenever we are considering this ring is a base ring, the ring base ring. The entire the ring system is also considered as base ring. Now, whenever we are considering the entire ring is base ring, simply called as quinoline. This is the more preferable name instead of giving the name by taking the base ring, then 4, 5, A, B. Now it is called benzo 5, 4, B, good. Right. But instead of taking this name, this one is the more preferable name because the trivial name is quinoline. For that reason, you need to use the name as quinoline. Whenever we consider 2, it's
Sir, 5 benzo 5 6 dash B, no sir?
yes, B.
5 4 you have written.
5,
Is it
4B. 5, 4B, pyridine.
4 or 6, sir?
It is not 6, B. Alphabetical.
No, sir. 5 6.
Yes.
It is
Sorry, it is 5, 6.
okay, sir. Okay.
5, 6, B, pyridine. Right. Now, here also, this is the ring. Quinoline, the number it also starts from here 2, 3, 4, 6. This is the base. But whenever we are taking the entire ring, the number continues. 6, 7, 8. This position. Whenever we are considering the base ring is this one, suppose. Now its common name is the entire system is considered as base ring. Now named as isoquinone. Considered as isoquinone. Or instead of the alternative nomenclature, this heteroatom containing ring is considered as base. Now benzo, this is the pyridine. Now the name becomes benzo 5, 6. Right. Numbering, labeling up with the alphabetical alphabets A, B, C, 5, 6, B, 5, 6, C, pyridine. Yes. Now, for this first one also, it is called Hazana. This one is isoquinoline or benzo 5, 6 ring. This is the way we are going to do the names for the single heteroatom containing fused rings with 2 rings. We can also sometimes use more than 2 rings are also appear like a carbazole like compounds, right? Now, here the question is always you need to follow the ring index for giving the system names of known fused ring system can be obtained from the ring index, which contains the list of ring structures in order of ring size arranged according to the number and type of the atoms present in it. This ring index table is always follows the 4.1 table. It is given in our book already. I have given the table of this table. It follows this table, right? And also this is the order given. This order is also important whenever we are taking the which heteroatom is more preferable than the others, right? Now, whenever we are going to consider the heterocyclic compound to give the name, we need to follow 3 rules. First, name the compound of the possible fused ring system are chosen from the list of recognized trivial names. I have already discussed. We need to give the name based on the trivial name. That is the first prior. The largest component have the recognized name is chosen. Indole, suppose this is the quinoline, isoquinoline are also example is the indole. Indole is also having nitrogen heterocyclic, that is fifth. Another one is this. Now we can take this one that is called benzo 1 2 3 4 comma 5 b benzo 4 comma 5 b pyrrole, right? Or other name is simple trivial name is indole, right? Entire we take the base name indole. So 4 comma 5 b. This is the way you need to give the name. That is the first rule. If first rule is failed, then consider in a fused system made up of 2 separately named components. One of them is chosen as the base component for the composite name, and other one is attached to the fused ring. Suppose the previous one, there is no common name for the entire base system as a benzofuran, right? Now in this case, this is base ring and this is taken as pyridine. Therefore, benzo used as prefix benzo 5 comma 4 furan. This is the second rule explains. Or other name, other compounds can also use. Suppose the pyridine, pyrazine, 1 pyrazine, sorry, 1,3 pyrimidine, called 1,3 pyrimidine. It is used with the heterocyclic 5-membered ring. Right. This is the 5-membered ring. Right. This is known as, now which one is considered as base ring? Because here this is one heterocyclic ring and with one heteroatom, right? This is another one with other kind of heteroatom. Same heteroatom, but 2 heteroatoms are there. Which one is taken as base heteroatom? Heterocyclic means it is the largest. It should be a largest ring. And it may be consisting with one heteroatom is more preferable. If 2 rings are having one heteroatom, if the ring which is a larger ring and contains the more number of that cyclic system is considered as base. So sometimes only one heteroatom is there, that is the largest ring. In such case also that is considered as base name, right? Here it is considered as base name. It is taken as prefix name. It is as prefix. Okay. Now this name is pyrrole. Its name is, and its name is, the larger ring name is pyrimidine. Name is pyrimidine. Now it is the prefix, is the root word or base word or stem word. Now the name becomes, again you need to give the name. Name is always starts with 1, 2, 3, 4, and 5, 6, 7, 8. Okay. Now need to give the attachments. Now this bond is given as A. I will change the is taken as A and B. What is the fusion bond here? The bond is A. A bond is the fusion bond. Now the name will be given as this is pyrrole. The prefix is always ends with the prefix should be given as pyrrolo. And ring system is pyridine, right? That's all. Pyrrolo. Pyrrole. The name is the pyrrole. The end in A. EV is replaced with, that is pyrrole. The E is replaced with the O, right? Now, pyrrolo. The fused bond is 1, 5. The bond label is A. The name is pyrimidine. Similar. Okay. Now, here the some of the compounds, some of the cyclic systems. Suppose if you have, this table is already given in our book also. It is the furan. If you want to give it as a prefix, that is named as puro. Exceptional, because here in the pyrrole, last E is replaced with O, but some of the exceptions are there, right? Suppose if you are using imidazole, if the subring system is the imidazole, then you need to give the prefix. Prefix is like this, imidazole.
Sir, here pyrrolo 1, 5, A alphabet only A is enough, sir. At B also nitrogen is there, no, sir?
Look at here the position. Always, whenever you are giving, suppose in this ring, in the previous case, I have taken the right. I'm going to keep the number like this. 3, 4, 5. Whenever we are counting the fused ring bond, we are going in opposite way. Similarly, I am also going similarly, right? The numbering starts with here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now the label alphabets are given like this. Suppose the number starts from here, 1, 2, 3, 4, 5, right? 6, 7, 8, 9. Suppose. Now the name becomes 5, 6 and A and B. 5, 6 B, but it is wrong. but it is wrong because the numbering from here is correct. IUPAC suggested by the 5-member ring, and most nitrogen is bind with the more sigma bonds is the more priority than the nitrogen with minimum sigma bond. Okay, that is the reason I am taking this nitrogen is the most priority position. Then the numbering starts from here 1, 2, 3, 4, 5, and whenever we are going to the alphabetical labeling for the bonds A, B. Now the name is Pirolo 1, 5, B, sorry, A.
Sir, second alphabet B will not come.
Yeah, B.
Second alphabet B will not
Yeah,
come,
B.
sir.
This is A, this is B. What is the fused bond here? This is the
Okay.
fused bond. We need,
Okay, sir.
the fused
Understood,
bond.
understood, sir.
Yeah, right.
Okay,
We need to
okay.
indicate the fused bond position.
Okay, sir,
The A
understood.
indicates the fused bond position, right? Yeah.
Okay, understood.
Then, right here, the table where we are. Imidazole. Imidazole is indicated with imidazole. Isoquinol. So the isoquinol part, whenever we are going to give the name, isoquinolin. Then name is isoquinol. Generally, this kind of words seen in small member rings. Whenever we are went to large member ring system, that means more than 4 nitrogens and nitrogen with sulfur, oxygen, and 2 oxygens, 2 sulfurs along with the nitrogen. In such case, we are using these words. Okay, pyridine, pyridine, pyrido, simply quinoline, quino, thiophene, thino. Is the full name. Thino, thiopheno. Generally, we are using the such a pheno. This is used as actually thino, not like thiopheno, right? This is the wrong. Here also, quinolono, quinilono, quinolono is the wrong one. Quino is the correct one. Pyridino is wrong. Pyrido is correct. Quinilo, isoquinolino is wrong. Isoquino, imidazolo is wrong. Imidazo, pirano, not piranolo is wrong, right? This is, you need to remember some. These are the exceptions. Simply here the pirol, the last is replaced with O. You get pirolo. This is the commonly in the cases, but these are the exception ones, right? Third rule, if the second component is added as a prefix to the name of the base component, the prefix is divided by the replacing the final E. Then this is the thing, what way we are going to give the prefix, right? The part of the heterocyclic is pyridine, pyrrole. The pyrrole is write the prefix place like including the O at the place of E. These are the exceptions. The third rule explained like this, right? I'm going to give some examples here how the name given. The first example, the same examples are taken from the your book. Okay, it is into which one is the base in which whenever we are going to select the base ring, type of heteroatoms present in it. Here the nitrogen is there and oxygen is there, in which the no nitrogen is more priority than the oxygen. Then oxygen is more priority than sulfur, more selenium. Selenium is more priority than sulfur. Then this is the way you are moving whenever we are going to select the base ring, right? And second, suppose here the larger member ring with nitrogen. Suppose we are exchanging these positions of oxygen and nitrogen. Even though oxygen in this larger member is the considered as the base, but in these two, oxygen and nitrogen, nitrogen is more priority. Even though nitrogen is present in the smaller member ring, that ring is considered as a base ring. Therefore, this is considered as base ring and it is not having any trivial name. It is not having any trivial name. Due to that reason, I am going to give the numbering first. 1, 2, 3, 4, 5, 6, 7, 8. When we coming to the atomic number, which one is having more atomic number? Which one is having? Please tell me. This is the general numbering whenever we are going to give the substitution position. But whenever we are going to give the name, we choose the different numbering. Different numbering like 1, 2, 3. These are the exceptional things. That is the reason I am going to give you the name 1, 2, 3 and A, B. The first position of the fusion system is the prefix. This is the base ring, right? Sometimes number is and A and B. In both case directions give the same numbering. That is the reason the name is given as Pyrano 2, 3, B, pyrrole. Yeah, here the exceptional one is, except why you need to take the exception means, look at here. This is the large member ring. This is the small member ring. This is the 6 member ring. This is the 5 member ring. Whenever you are going to give the numbering, first you choose the numbering from this position 1, 2, 3, 4, 5, 6. Later 7, 8, 9. Then A and B. This is the way you need to give the name. Pyrano 2, 3, B, pyrrole. This is the name, right? Suppose, just a minute, I will show you what happened.
Excuse me, sir.
Yes, just a minute.
Please tell me again what is the numbering? How it is numbering?
Yeah, write it. Okay, look at here. Is it appear to you all?
Okay, sir.
Yes, sir.
I am selecting this structure. This is the structure, right? I'm selecting this structure. I'm giving structure to name. What is the name? Pyrano 2, 3, B, pyrrole. This is the exact IUPAC name, right?
సార్ ఆ డయాగ్రామ్ కి 1 2 3 4 5 ఎందుకు ఇవ్వలేదు సార్ 1 2 3 అని మళ్ళీ ఇచ్చారు.
Yes, I'm going to give again numbering. Look at here. The preferable numbering Now I'm considering the numbering. 1, 2, 3, 3, 4, 5, 6, 7. Not at all. We're not giving 7 like this. 7, 8, right. And give the alphabetical labeling A and B. That is also correct. You can also give A and B like this. Right. And another proposal is also there for this numbering. Once this become a base ring, some of the people are giving the number
And how
like
it
this.
is A and BB?
Right. First listen, I will explain. Right. 2, 3, 4, 5, 6, 7, 8, and okay. In these two different ways, they can give the number. They are giving the numbers, right? And how this A and B is generated. Always, you preferably consider the carbon heteroatom bond first. Whenever you are giving the labeling with the alphabetical elements, right? This carbon nitrogen, it is also considered as this bond is considered as A. Next sequence bond A and B, C, D. Also can you see E like this. Again this bond, again this A, right? And this becomes B. AB, AB. This becomes C. Here A, AB or A, B, C, A, B. But this kind of numbering is sometimes it is very ambiguous. Okay. Always you need to remember that you need to consider the fused rings. Suppose this is ring in the fused ring system, it is the heteroatom. It is the heteroatom like this. Suppose example. Always the heteroatom is connected with the fused ring bond or fused bond, then that becomes A. Suppose sometimes it becomes maybe here, right? Now you need to count the distance from the or gaps between the fused bond and the heteroatom. Now suppose two sigma bonds are there, it will give the A, B, C like that. Or in this case, it becomes A, B, right? Whether it is the C or B, it is by the base ring. Whether it is the base ring, you need to take B. Suppose it is the base ring, you need to take it as C. In the name, we are using B sometimes. That means you are using the base, you are considering that this ring is the base. Or if you are using the C, that is depends on the this ring is selected as base ring. Like this here. Pyrino, pyrano, 2, 3, B, pyrrole. Sorry, pyrrole. In the previous case, quinoline and isoquinoline, you can say, right? In the quinoline and isoquinoline, right? A, B, C. Whenever we are giving the name benzo 5, 6, C. In the quinoline, 1, 2, 3, 4, 5, 6, A and B. 5, 6, B, pyridine. It is 5, 6, C, pyridine. That is the difference. Two are isomeric. Two of them are isomeric. Then, coming to next example. A system with nitrogen, without nitrogen, choose the ring containing an heteroatom which occurs highest. So whenever we are comparing the sulfur and oxygen, for example, which one is having highest atomic number? Tell me, which one is having the highest sulfur and oxygen?
Sulfur.
Sulfur.
Sulfur is the
Sulfur.
highest atomic number element, right? Now, this is the ring system, suppose. Now, in this highest atomic number containing RTS, this is the prefix, and this is as base. The nitrogen and oxygen containing what we have taken? Base ring is what?
Nitrogen.
Yeah, nitrogen ring is taken as, pyrrole ring is taken as base ring. Here, oxygen and sulfur is there. Highest atomic number containing ring is considered as prefix ring, and most priority, like lowest atomic number containing heteroatom is taken as base ring. Therefore, oxygen heterocycle is considered as base ring, sulfur heterocyclic is taken as prefix. Then, coming to numbering, how the numbering is given. Whenever you are giving the number, just detach it. It is detached from the fused rings. Detached from the fused ring system, right? This is the furan. Correct? Furan. Now, give the numbering 1, 2. Now, this bond is the fused one in the cyclic system, fused ring system. This is the fused bond. Now, give the alphabets, alpha or AB, like this. Now, the same will be carried to this fused ring system. 1, first 1, 2, 3, 4. Okay, you forget remaining two. Give the alpha, vertical order A, B. This is the heteron is linked with the ring fused ring bond. Therefore, it is taken as A, and fused bond is taken as B here. Then the name is, the prefix is this one. That is thiophene is the thiophene ring system is the prefix. Then it is in the thiophene ring system. What is that? Thiophene. We need to use thieno, right? The numbering 2, 3, B bond. Second B, furan. Furan, N, sorry, it is not M. Yeah, furan. Suppose this is the second example, right? And we're coming to third example. You consider the ring. If there are more than 2 rings present in the component containing the more than 2 nitrogens, then the greater number ring is chosen as the base ring. Greater number ring means the number of more carbons is considered as greater number, right? For example, the cyclic nomenclature, there is no use in it. So many exceptions are there. So many exceptions are there. But all the exception you need when you remember when you are doing the more practice, or otherwise when you are dealing that molecule, you are understanding that molecule, right? Suppose when you are going to research, you are going to do a synthesis of this molecule. Whenever you are after synthesizing, then you are studying about that from the literature, from the other sources. You can get its original name, trivial names, actual IUPAC name. Okay, all these things will be learned by the experience only. By simply we cannot decide the name. Always we need to compare it to the literature. By doing that practice, you can understand the nomenclature. Then only we can give the name of the heterocyclic compound by simply seeing the molecule, right? Here the system, one ring system is with the 2 nitrogens, one ring system with 1 nitrogen. Then in which one is known as the trivial name is there in this? Right. Look at here. This is trivial. We are already previously delete quinoline, right? Right. Next, second part, other part of the cyclic system is this one. It is the unknown one. We need to give. There is no trivial name for this. We need to give the. This is the prefix. The nitrogens are there. It is not considered as base ring. And this one is the larger number of carbons are more, and it is a known trivial name, that is quinoline. Quinoline is considered as base. Now the name is given as how the name is given, right? You detach again. You detach this one fused system. That means you need to consider the only quinoline one from this thing. You can right. Give the numbering 1, 3, 5, 6, 7, 8 lines. Now you need to attach it to this fuse, because this is all entire system. We call it as quinoline. Then you no need to consider this fused bond. Which one is considered? This one is this fused bond is the reference bond. This fused bond is the reference bond. This fused is considered reference bond, right? With reference to this fused bond, you are going to give the name for this compound. This one, this cyclic system. Now it is known as pyrazine. This heterocyclic is called it as pyrazine. Now the base name is is pyrazino. Then give the entire name. Prefix is this one, and the base name is this. Right? Pyrazino. And the numbering 2, 3. 2, 3. Now they give the alphabetical indications A and B. E quinoline. That is pyrazino quinoline. Pyrazino quinoline. Right, we have several compounds to discuss, but it takes very long time. I will simply give the structure and name.
Sir,
Yes.
just to bring the screen down, no, sir.
Yeah. Okay. Okay.
Okay, sir.
Right. Other, if I remember heterocyclic, simply just writing the name, and if you have, whenever you are reading, you can ask me, I will tell you. Here the nitrogen is here. Nitrogen. It is a 7-member ring. 1, 2, 3, 4, 5. Yes. Yeah, this is a 7-member ring. Put the double bonds position. Right, this is the, yes, in which one is taken as base ring? Nitrogen containing a large member ring, then that is we consider as base ring. We consider as base ring. Then its name is azipine. and it is taken as prefix. Then its name is one oxygen is there, one nitrogen is there. Now this ring system is called oxazole. Its name is oxazole. Now it is the base name. It is the prefix name. It is the base name. Then what is the name? First give the numbering. I'm going to give the numbering like this: 1, 1. Somewhat different here. Please understand. The numbering is different. 1, 2, 3, 4, 5. And the labeling A, B. Four. Oh, 1, 2, 3. Okay. A, B. This one is given here. As per the literature, like this. Then the name is oxazole. The name 2, 3, A, or ZP. This is the name. Not 1, 2, 3. I will show you the IUPAC name generator. So it is where it is. Yeah. Right. This is the cyclic system we discussed previously. Then what is the name? Click it. Oxazole 2, 3, A, cycline 2, 3. Then the numbering starts with 1, 2, 1, 2, 3. And the alphanumerical indications, this bond, CN bond is indicated with the A, there is a fused bond, and the CO bond is indicated with the B, A and B. That is the reason its name is oxazole 3, 2, A as P. Right. Next. The third one, the fourth one, isoxazole derivative. Isoxazole. Isoxazole. Then it is fused with pyrrole ring, like this. Pyrrole ring. Now, what is the name for this? Is it is considered as ring is considered as prefix. Now it is its name as 4H pyrrolo. H pyrrolo. That means 4H pyrrolo. 1, 2, 3. Actually, fourth position is like this, but whenever we view the numbering, 1, 2, 3. Whenever we are indicating the substitution, numbering is like this. But whenever we are giving the name 1, 2, using position, it is the position. 1, 2, 3. 4, 5D. Isoline. Numbering A, B, C, D, E. Yeah. The NO bond is considered as A, B, C, and D. According to the name, I am giving like this. But as per the UPSC rules, it will be considered as A. It is you consider B. It is need to consider the C. But in the literature, its name is given as 4H Pirolo 2, 3 D, not B. Yeah. Pirolo D isoxazole. Right. Another last one. 5-member ring, so 4 nitrogen. This is the molecule. 2 5-member rings are fused with this bond. And numbering, this is called as imidazole ring. This reaction known as imidazole. This is called imidazole. This is known as two nitrogens are adjacent to each other in the 5-member ring. It is called as imidazoles. 1-3 positions are there. That is called imidazoles. Okay. For example, actually this is my research work. 2-amino imidazole. Suppose in the same way, taking benzene with that is 1, 2. Okay, 1, 2. So it is amino. 1, 2, 3. This is 3 amino pyrazole. 3 amino pyrazole. Okay. Now this is the imidazole ring. This is the pyrazole ring. Now these are considered as the name. Which one is base ring? Which one is prefix ring? Means the imidazole is considered as prefix. This is considered as base. Now the name is imidazole. 4, C pyrazole. Now the numbering, how the numberings are given. Actually, numberings are given like this. Pyrazole is started. This is the base ring 1, 2, 3, 4, 5. Pyrazole is C ring. It is NN bond is considered as A, B, and C. Imidazole, only imidazole, not imidazole, 4, 5, C pyrazole is the name. Okay, this is about the nomenclature of usual ring system. These are the exceptions one, and more frequently appear in the whenever you are reading the heterocyclic compounds. And the next concept, coming to by excessive and by deficit. System is important for the short answer question. Now look at here. Here the comparison is you can easily understand that. And another thing, in the benzene, one of the carbon is substituted with hydrogen, and take any hetero that means is having exceed nitrogen H, is having a lone pair, and oxygen maybe having a lone pair, and pair, any other heteroatoms. Now this is the 5-member ring. Five-member ring. This is a 6-member ring. Look at it here. These three are aromatic. All three are following 4n plus 1. Therefore, aromatic. Okay, aromatic. Whenever these aromatics are comparing, we can here I'm showing this ring. How this 6-member ring is. These are the 5 unhybridized orbitals perpendicular to each other, and each having one electron. Each having one electron. In the benzene ring, all 6 electrons are arranged like this. All 6 electrons are form a cloud. The cloud is like this. That is arranged like this. That means this cloud means in both are indicating the graduation, delocalization. Means all 6 electrons are equally distributed on the all 6 carbons. 6 electrons are distributed on the 6 carbons. Then this is as an electron density. Okay. Normal electron density. A normal electron density. Now when we coming to 5-member ring, this is the 5-member ring. Consider the pyrrole. Right. This is pyrrole. It is having one pair of electrons, and 2 pi bonds are 5 electrons are here. 2 pi electrons are here. Whenever representing in the form of a orbital representation. Is having one hybridized p orbital, another unhybridized p orbital, 4 unhybridized p orbitals, and here one orbital with a pair of electrons. Now each one is having, each carbon is existing with one electron. This 5-member ring like this. These 5 electrons and this lone pair of electrons, 6 pi electrons or 6 electrons are form the cloud like this. above and below, the ring system is having a cloud, electron cloud. Now this electron cloud is are distributed on the 5. We comparing this electron density with the ring, it is more electron density because 5 electrons are shared by 6 electrons are shared by the 5 electrons, but here the 6 electrons are shared by the 6 electrons. Then when we are comparing these two, this each carbon or nitrogen having the more electron density than the carbons present in the benzene. Now this kind of systems are known as pi excessive system. The system is known as pi excessive system. Now coming to here, the pyridine, the 6-membered ring is the pyridine. This pyridine we are showing suppose pyridine is here. For each carbon we put one hydrogen orbital with one electron. It's 5 electron in the carbons. One electron, 2 electron, 3 electron, and 5 electron. Here the lone pair of electrons is there. Lone pair of electrons are there. But this nitrogen is already forms a pi bond with this. Right? Already one electron is shared between them. Therefore, a pair of electrons is between them. Now, this pi electron, this lone pair of electron will not involved in the aromatic system. Right? Moreover, this nitrogen electron will not completely donate to the ring. Therefore, some localization is there on the nitrogen. That is, the electron is particularly constrained to the nitrogen. Then, whenever we are comparing the benzene ring system, here the 6 electrons are distributed on 6 carbons. Therefore, this is a general electron density. Whenever we are coming to here in the case of pyridine, there is a lacking of electron density when we compare to the benzene and pyridine. Now, there is some electron deficiency is observed. This electron deficiency is denoted as, for the systems are known as deficient systems. Most of the cases, if the number of electrons are more, then shared atoms are less. Those systems are known as pi excessive systems. And some cases, even though the size of the benzene ring and heterocyclic rings are the same, but the electron distribution is having some deviation. In such cases, the electron cloud is not equally shared by all the 6 atoms, and it causes some deficiency of electron cloud or electron density is causes. That is the reason the system is known as pi deficient system. This is known as pi excessive system. This is known as pi deficient system. Okay. This concept is very much important whenever we are explaining the aromaticity and stability and reactivity of heterocyclic compounds. In some cases, only 5-membered rings are involving the substitution reactions. Only in some cases, only 6-membered rings are involving the reactions. Why these reactions takes place is explained by this pi excessive and pi deficient concept. Right? This is about the concepts involved in the heterocyclic compounds or power to that. Now we have the compounds. We have the compounds in our syllabus. What are that? Benzofuran. Yes. We have the compounds like benzofuran. The structure is like this. This is the benzofuran. Second one is that is pyrrole ring is attached to that. To these two compounds, along with these two compounds, carbazole. This is known as carbazole. And the fourth one is quinoline. Quinoline is already known. In the non I have given 2 to 3 times per cycle. And isoquinoline. Isoquinoline. And the sixth compound, acridine. Carbazole, but instead of 5-member ring, we are inserting the 6-member ring here. That is a quinoline derivative is almost it is also derivative. So, yes, this is the acridine. For these compounds, you need to prepare the nodes. 3 synthesis. 3 synthesis properties. I have the notes, I will say if you require properties. And 3 at least physical properties. And aromatics. Aromaticity and isotopy. Where it is coming from. These things you need to prepare. For example, if benzofuran is there, for that you need to prepare the preparations. The preparations always you need to prepare that named reactions. Named reactions means suppose in the benzofuran synthesis, Claisen rearrangement. One of the Claisen rearrangement is there. Just a minute. In the indole, when you come into indole synthesis, Fischer indole synthesis. Fischer indole synthesis. Right, mid-lung indole synthesis. And research indole synthesis. Research indole synthesis. These are named reactions. Whenever the named reactions are appeared, you need to prepare that named reaction. Bischler reaction, the Bischler reaction, Bischler indole synthesis. Bischler indole synthesis. Right. When you come into physical properties, indole is the colorless liquid, colorless solid, and the melting point is 52 degrees centigrade, and it boils at 254 degrees centigrade. It is less basic than the pyrrole due to high conjugation. It has 10 pi electrons, therefore it is aromatic. It follows the Huckel rule. And chemical properties, it is undergoing electrophilic substitution reaction, and more preferably it takes the electrophilic substitution reaction at a third position. and major product is produced at the third substituted product. And it is also undergoing second position substitution. The position here it is also substituted, but more preferably it takes the substitution reaction at third place, and it is participating in the acylation reaction at third position, alkylation, Wills-May-Hack reaction, POCl3 reaction, POCl3 DMF. It produces an aldehyde, indole aldehyde will be generated, and it is also undergoing the Reimer-Tiemer reaction with the chloroform and potassium hydroxide. It leads to the formation of aldehyde, and also rearranged product is generated, that is 4-chloroquinoline is generated. Managed reaction, managed electrophilic, that is nucleophilic addition reaction may also undergoing on the indole, that is at the third position. It is reaction with the alkyl lithium, organolithium reagents at second position. That leads to when nitrogen is free, then that is NH form is there. Therefore, this H is replaced by the alkyl group. Suppose this H is nitrogen is substituted with any alkyl group, alkyl or aryl group, then it is undergoing its second position. It is also undergoing nucleophilic substitution reaction. The nucleophilic substitution reaction majorly takes place at second position, and it is also undergoes reduction reaction that leads to the formation of saturated dipyrrolate, that is double bond, preferably undergoing addition reactions when we are using the lithium aluminum hydride. Whenever we are using the Beech reduction like sodium with oxide reduction or liquid ammonia reduction, sodium in liquid ammonia, that is also undergoing these 1,4 positions of benzene ring is undergoing the reduction. That means this position will be saturated. This becomes a double bond, and this becomes double bond. This is a double bond. This is the product. Whenever it is treated with palladium and hydrogen, it leads to the formation of octahydroindole compound. That is fully saturated indole will be generated. Now, when you're coming to benzofuran, this benzofuran is also called benzobifuran, or its isomer is also there. Benzobifuran is isomer is also there. That is benzofuran isomer. Like this is the benzobifuran. Sorry, benzocifuran. This is bifuran. Now, benzofuran was earlier known as fumaron. It was discovered in Coulthard by the Kramer and Spikler. A number of derivatives of benzobifuran are present in plant products and have a pharmacological application. Benzofuran is highly aromatic and is a resonance hybrid of the. It can generate the different kinds of resonance hybrids. It can be synthesized from the coumarin. The coumarin is like this, a plant material, the coumarin. Generally, it is similar to flavonoids, but the position of the coumarin, we can synthesize coumarin from the coumarin by applying the bromine in chloroform, followed by treating with potassium hydroxide. That leads to the formation of benzofuran rearrangement product. And internal Claisen type rearrangement with the sodium salt of salicylic acid, treated with the alpha bromo ethyl acetate, that leads to the formation of substituted benzofuran. All these notes I can share with you. You can prepare well. Okay, very clear notes I will send you, or otherwise you can take the reactions from your book also, right? If you have any doubt during the preparation, you can ask me. Then today I'm going to conclude this session. If you have any doubt, you can ask me.
Sir,
Yeah.
if there is question about quinoline, how many reactions we will have to write for 10 marks? For
No,
nucleophilic or
Yeah.
substitution reactions,
Here,
how many reactions are needed?
please listen. Whenever you are learning these preparations means you need to learn the reaction, each reaction, and its mechanism also. If mechanism is not given in our book, you are lucky. Okay, just to prepare the preparations, that is synthesis. 3 synthesis and 3 properties. In the physical properties and aromaticity, isomer. For every compound, you need to prepare 3 substances. reactions of chemical properties or chemical reactions and the physical properties, and whether it is element or not, it will element. These things you need to learn for each compound. That means here how many compounds? 6 compounds are there. 6 into 3, 18 plus 18, 36 reactions and physical properties. That is the burden, preparation burden to do. Okay.
Okay, sir.
So in the Sunday class, I'm going to start the last block 4, natural products. Natural products. This includes alkalides, terpenoids, carbohydrates. Okay, that is the lesson I'm going to start on Sunday. Thank you. Is there any questions?